Okay, you're right. Welcome to your video tutorial on inequalities and inequations. Today we are going to learn about what these things are and how we can work them out and how they fit into our study of equations. Okay, so what is it? Well, do you remember what an equation was when we looked right back at the start of the term? An equation is an expression that contains an equal sign. Okay, so there's something on the left equals something on the right. Now, an inequation is an expression that contains an inequality sign. You probably should be used to some of these from primary school. There's things like less than, greater than, less than or equal to, or greater than or equal to. If one of these inequality signs has a line underneath it, that means whichever way it is, less than or greater than or equal to. Okay, so there's 4 different inequalities that you can have. So an inequation can be solved by doing the same to both sides, just like with an equation. Okay, so if we were trying to get things away from the pronumeral with equations, we're trying to do that same thing with inequations. And we do that by doing the opposite operations. Now, another important thing to note with inequations, if we multiply or divide both sides by a negative number, okay, so if there's a negative number like -2 and next to that pronumeral there's a -2 against the pronumeral, okay, that reverses the inequality sign. So that's a really important thing that you'll have to remember. If we multiply or divide both sides by a negative number, it reverses, so I have to flip my inequality sign. Let's have a look at a few examples. So the following says, solve the following inequation by doing the same to both sides. So in replacement of that equal sign like I saw in my equations, I now have an inequality which has an inequality sign. And this sign is pointing to the left and it means less than. Okay, so if 2x is less than 4, okay, in order to get that x by itself, I need to divide this side by 2. If I divide this side by 2, I must do the same to the other side. Now, why did I divide this side by 2? Well, it was 2 multiplied by x. If I'm trying to get the x by itself, I have to get rid of that 2. I get rid of that 2 by doing the opposite operation, so division. So that would mean that x is less than 2. And that's how I solve the inequality. Let's look at another example. Solve the following equation by doing the same to both sides. Okay, this time I've got -3x is less than 12. Okay, this time I must divide both sides by -3. Now, why am I dividing both sides by -3? Well, -3x is less than 12. Okay, that means I need to move everything away from the x. What's sitting right next to the x is a -3. When something's sitting right next to the pronumeral, it means multiplication. In order to get rid of it, I divide it. Stop. What was that thing I wrote down before? I said if I'm multiplying or dividing a side by a negative number, I must reverse the inequality sign. So this actually becomes x is greater than 12 divided by -3 is -4, okay? So what's happened there is this sign I have flipped because I have been dividing by a negative number, okay? I've been dividing both sides by a negative number, so I must flip my sign. Last example, okay? This one here is a tricky one. It's going to involve a few steps. It's saying everything on the top is divided by everything on the bottom. Okay, so I don't get rid of the 2 from the x, I don't get rid of the subtract 1, I actually have to get rid of the 7 because that is the thing on this left-hand side that is furthest away from my x, okay? So I actually have to multiply both sides by 7 in order to get rid of this 7 down here. So then I'm left with, if it's divided by 7, multiplied by 7, that cancels out. So it's 1 subtract 2x is greater than -1 multiplied by 7 is -7. Let me write that sign a bit better. That was a bit dodge. Okay, greater than. Okay, so what's the thing on this left-hand side that's now furthest away from my x? Okay, I've got the -2 that's next to it. I've actually got the 1. Now, is that one a positive one or a negative one? Well, it doesn't have a sign in front of it. A reminder that I work it out if it's positive or negative by the sign in front or the value that's put in front of my number. Now, this 1 doesn't have anything in front of it here, so it must mean it's a positive. Okay, so what I need to do to this here is I need to subtract 1 from this side. If I subtract 1 from this side, I have to subtract 1 from the other side, okay? So this 1 subtract 1 cancels out, okay? Now I'm left with working out the right-hand side. -7 subtract 1. Careful, careful. It's not -6. It's -8. If it's -7 degrees and it gets 1 degree cooler, it becomes -8. So I have -2x is greater than -8. Okay, right. Now I need to get rid of the -2. Multiplication is going on at the moment between that -2 and the x, okay? In order to get rid of it, I need to divide this side by -2 and divide that side by -2. But whoa, stop again. What happens if I divide or multiply a side by a negative number? I need to flip this guy. I need to flip my inequality sign. So this side becomes x. I flip this side, okay, because that's -2 divided by -2. They cross out. I flipped him, and then it's -8 divided by -2. Well, 8 divided by 2 is 4, and negative divided by a negative is a positive, so it becomes 4. So x is less than 4. X is less than 4. Okay, now we're going to have a little bit of a look at how we can actually express this answer. So, sometimes we're asked, once we've solved the inequation, to show it on a number line. There's a few key principles that you guys need to be able to understand. I've just shown 3 basic answers, okay? So say I solve these inequations. This first one here says x is greater than -3. Now, if it's greater than, okay, I do an open circle over the number, so -3, and it's greater than, I put the arrow going this way. And then above that, I write x is greater than -3. That's how I express it on a number line. Okay, if I have this one by comparison, x is less than 4. Okay, it's less than, I again do that open circle above the 4. Sorry, that was meant to be above the 4. That was a bit dodgy. Let's try that again. Okay, open circle above the 4, and then it's less than, so I'll have my arrow going the other way, and then above it I write x less than 4. Okay? The only time where it gets a little bit tricky is if I have a greater than or equal to. If it's greater than or equal to, instead of doing an open circle, I actually do a coloured in circle. Okay? And I have my arrow going up. It doesn't matter how long I draw it, generally, so it indicates it goes for a little while. X is greater than or equal to -2. Okay? That's how I represent these things on a number line. Similarly, if I had a less than or equal to, so say I had x is less than or equal to 5, okay? If it's equal to, I colour in the bubble, okay? And I do the line going down, x is less than or equal to 5, okay? So if it's equal to or less than or greater than or equal to, make sure you colour in that bubble. And that's it, guys. That's inequality signs with inequations and representing them on a number line.